Hello and welcome to Console Cowboys. So in the last video, we went over some blocks and transactions, filtering transactions, using bytecode to find functions that are being sent within transactions. In this one, we're going to take a look at pending transactions. So all of the transactions that are sitting in the mempool, which have not actually became real transactions yet. This is where you run attacks like front running and sandwich attacks. In order to monitor the mempool, we're going to make a couple changes to our template. So here's our regular code. The only difference here is that I used a HTTP on our variable instead of just saying Infura. And I made one with a WS, and that's for WebSockets. So if you go to the infura.io website, you will see a tab right here for our HTTPS, which is what we used before, and then another tab for WebSockets, and that will give you a WebSocket connection to the blockchain. So grab that and paste it into your code like this. Then we need to import a couple extra things. So first off, just like our subscribing to events, we're going to put in the JSON and the async IO libraries because we're going to make asynchronous calls, as well as we're going to parse out JSON. So we're going to need both of those. We will also import from WebSockets connect because we're going to use connect with our WS URL in order to subscribe to the pending transactions. And then the last thing you need to do is you need to make sure that you're on the newest version of Web3 and the newest version of WebSockets, because there was a mismatch in version 3.10 of Python where the WebSockets and the Web3 interact in a different way, and you're going to get errors if these are both not upgraded to the newest version. So you can upgrade them quite simply with a pip install ---- upgrade web3, and then the same thing for WebSockets. Pip install ---- upgrade WebSockets, and you should be good to go. So in this code, we're going to be handling it very similar to our subscribing to events with our async IO connections. So let's take a look at that code. In that code, we had a main function. Our main function called an event log loop. In our event log loop, we grabbed our events that we subscribe to, and then we used our event handler to parse out that data and print. So we're going to do the same thing within our pending transactions. So I'm going to paste in this code here like this. Inside of our main function, we are going to call our subscribe pending transactions with an asynchronous call, but we're going to do this inside of a while true loop. We want this just to keep running until it's done, and we're going to say async io.run. Just like in the subscribing to events, we're going to subscribe to our pending transactions function. Now inside of here is where all of this stuff happens. I'll paste in some code here and I'll explain what it's doing. It's pretty simple. So here's what we're going to do. We're going to say, let's make an asynchronous call to our Infura WebSockets URL that we defined up here. And we're going to use that to connect to the blockchain and give us back a WS variable that we can use to run WebSocket commands. Now, what command do we want to run? Well, we want to await the send command, and in the send command, we are going to do a ETH subscribe to new pending transactions. Now, where did I get this? Let me show you. While searching around for documentation on pending transactions, I came across the Alchemy page, and it has a documentation section for WebSockets and has a new pending transactions function. With this new pending transactions function, they have some examples. So they have a JavaScript example that shows a Web3 ETH subscribe. We don't have subscribe within the Python version for the new pending transactions. However, we also have a way to do it manually with this WSCat, make a connection to the blockchain, and then send over a call subscription with the same exact value that you saw in our script right here. So we made a connection to the blockchain, and then we're just going to subscribe this way, and we can use that for our subscription to pending transactions. So we can just do it a little bit more manually like we did it. And this will give us our result. Our result gives us our ETH subscription with our subscription value and a result, and the result is our transaction hash. So I will link this documentation in the description below for you, so you can grab that and take a look and then copy paste this into your script, and you should be good to go. And while you're in there, make sure to subscribe to my Twitter as well. The link is also in the description. Now let's hop back in the code. So now we have a subscription to our pending transactions, and what we have to do is now we have to receive them. In order to receive them, we'll create a loop that runs forever with a while loop. We'll say while true. And in here, we'll put some code that allows us to receive those pending transactions. So what are we going to do? Well, we're going to create a pending transaction variable, which is going to contain our pending transaction. That is going to come from our WebSocket connection using a receive that waits for that. It'll time out if it goes more than 15 seconds. And all we're going to do is wait for those pending transactions with our async IO connection. And then once we get them, we'll put them in that pending transaction variable that we'll send over to our event handler and we'll do something. This will work perfectly fine as is. However, sometimes you're going to get some weird errors based on the data coming back. So let's catch those exceptions. As well as another thing I noticed, if you let this run for a little while and then you try to cancel it with Control-C or Control-Z, it won't actually work. It'll just override it and keep running. So let's also catch our keyboard interrupt and then exit the program for us. We can easily do this with a try except pattern in Python. So we'll say try. And then what do we want to try? Well, we want to try to run this code right here. So we'll indent that. And then we'll say accept. And what do we want to accept? Well, first let's accept our keyboard interrupt. So if it sees us hit a Control-C, it will exit the program. That'll help us so that we don't end up in this loop that we can't kill off. And then also other errors can crop up that just crash out and then we don't get our pending transactions. So we can just say accept. And then under that, we'll just put a pass. However, the caveat with that is we're going to pass any error through. So if we're getting weird results and we're not getting our pending transactions, you might want to remove this code here and see what kind of errors are coming back so that you can handle them correctly. This should be fully functional now to subscribe to our pending transactions, grab us a pending transaction, and send it over to our event handler to parse. In order to parse this, we're going to put it into the JSON format, and then we're going to print that out and see how we can parse it. So let's say transaction equals json.loads, and we'll put in our pending transaction right here. And then let's print that out. We'll say print transaction, and then we'll hop into the terminal and print that out. All right, so it looks like we got an error. It looks like a value error of function subscribe pending transaction. So that would be this function. Yeah, so right here where we're calling it, we have to put the parentheses when we call that. That's the only thing we screwed up there. So let's run it again. And we get back some data here. So if you take a look at this, we have our method, which is ETH subscription, with our params of subscription. And here's our subscription value. And then we have a result. And a result value should be our transaction hash. So if I grab that and we go over to Etherscan, we can look that up. And that is a pending transaction that hasn't happened yet. It started about 28 seconds ago, or 23 seconds ago, sorry. And we can look at what that is. We can say, okay, this is an execute function. And here's the input data that's in there. So this is a pending transaction. If we wait a little bit, there we go. It turned into a success. We have 3 block confirmations, and this is the block that it's in. So perfect, that's working great. So the next thing we need to do now is we need to parse out these transaction hashes. So let's do that next. So back in our event handler, let's say tx hash equals transaction. And then what do we want to grab from the transaction? We want to go into our params and then go into that data, and there's a subscription and a result. We want to grab the result right here. So we're going to say params, and then we'll go one deeper and we'll say we want to go to the result. And that should grab us our data that we want, which will be the transaction hash. And right here we'll say just print out the transaction hash and take a look at what we're getting. So now we'll run this again. And it looks like we're getting some transaction hashes back. So if we grab one of these, and we go on to Etherscan, and I'm going to paste this in. We should get a pending transaction that's happened 10 seconds ago. It just got a block confirmation. And again, we could take a look in here if we want. Looks like it's a 0x, which is just a transaction. It's not actually, making a function call. Okay, perfect. So now what do we want to do with this? Well, we want to take all of these transaction hashes and we want to pull back all of the transaction data. So let's do that. We already know how to do that. All we have to do is say web3.eth.get_transaction. And we'll just put our transaction hash in there and we should be good to go. So let me run this now. And this should get all of our transaction data with those transaction hashes. And it looks like it's pretty good. So in here we have our block hash, which is none because this is a pending transaction, doesn't have a block hash yet, hasn't happened. We have a block number, also none because there is no block number yet. We have our chain ID of 01, which is the Ethereum mainnet. We have our from variable. We have our gas price. We have our input data. We could parse this out and look it up on that 4-byte lookup to figure out what it is if we want. But the main point is that we have all of our data and a fully functioning program we can use to monitor the mempool if we're going to run some front run attacks, some sandwich attacks, if we want to start running some kind of monitoring to see where things are going to, where things are coming from, how they're interacting with smart contracts, parsing out on functions on how they're calling these smart contracts, or anything you can think of. So now think about what you would do with these pending transactions, what you might want to look for, and just try to add in some functionality to this script so that you can start monitoring on whatever it is you're interested in. And then in the next video, I'll add a little bit of code in here and we'll monitor for a few things before we finish off this part of the series. Now, if you're not familiar with the mempool at all, I'll also post a video in the link below that goes over the mempool and it goes over sandwich attacks and front run attacks, which is part of another series that I have. I believe it was in the Ethers Blockchain Basics series, but it'll give you all the information on how this mempool works and why it's there, etc. So hopefully you learned something in this one. If you did, follow me on Twitter below, hit the like button, all that great stuff, and I will catch you in the next video.